Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem chef and difficult contests with the code CHFTIRED. Difficulty level of this problem is cakewalk and there are no such prerequisites to solve this problem. This appeared in the FAB challenge of 2018. So let's get started with reading the problem statement. It's written here that in each problem there are many hard tasks that chef cannot solve. However, he knows that he can become a good problem solver only if he works hard. Therefore, he has a problem in mind for you. You are given two positive integers a and b, and we can apply the following operation multiple number of times, including zero number of times. We choose an arbitrarily positive integer d, so the only constraint is d should be greater than 0 because it's a strict positive integer. And then we perform one of the following actions. Add d to a and add d minus 1 to b. So originally, before the operation, if the values are a and b, after the operation, one kind of operation we can perform is add d to a. So the new value will be a plus d and add d minus 1 to b. So the new value of b will be nothing but b plus d minus 1. This is one operation. The other operation that we can perform is add d minus 1 to a, add d minus 1 to a, and add d to b. So this is the second operation that we can perform. So there are two kinds of operation that you can perform. You can add d to a and d minus 1 to b, or you can add d minus 1 to a and d to b. These are the two kind of operations we can perform, and at each step we can perform one of the two. So at each step you have two possibilities. You can either perform this operation or you can perform this second operation. And we can perform this, this steps multiple number of times. So you can perform many number of operations as many times as you want, as long as at the end of the operations you're able to make a equal to b. At each step you have two choices. You can either do operation type 1 or operation type 2. Let's say that at the first you start here and then you perform operation type 1, which means that your a value was now after applying the operation new a value will be a plus d and new b value will be b plus d minus 1. If you after this again you can perform this or this. So let's say you perform this second operation. If you perform this second operation, then the new a and b values will change according to this. So basically what I'm trying to say is that we can perform this operation any number of times including 0, and at each step you have two choices. That is, the operation can either be add d to a and d minus 1 to b, or add d minus 1 to a and d to b. This is all I wanted to reiterate. Let's go to the sample cases. Now we have very small and nice sample case that says a equal to 5, b equal to 7. There are two types of operation that we can perform at each stage and we can choose. Let's say that we choose our d equal to 1. If our d equal to 1, this is a valid d. Why? Because d is greater than or equal to 0 and this is a strictly positive integer. Then what we do is, let's perform the type 2 operation. What is type? There are two types of operation basically. There is add this d to a and add d minus 1 to b, or add d minus 1 to a and d to b. These are the two kinds of operation. If our d is 1, what we can do is we will perform the operation where we add d to a and we add d minus 1 to b. So which type of operation was this? This was basically type 1, sorry. This was type 1 operation where we add d to a and d minus 1 to b. So if we perform the type 1 operation, the new value of a will be 6. This is 5 plus 1, that is equal to 6. New value of b, what will the new value of b will be? We are adding d minus 1 and d was basically 1. So 1 minus 1 is 0 and this remains 7. So the new values of a and b are a is 6 and b is 7. Let's again continue this. Let us say that we continue performing operation of type 1. This is operation of type 1. This is also operation of type 1. Again, what we're doing. So what is operation of type 1? We add d to a. So the value of d is 1 and we will add that to the new value of a, which is 7. And the value of b becomes b plus d minus 1, which is 7 plus 1 minus 1, and b remains 7. At this juncture, we notice that a and b are both equal and we stop. So we found that there is a way to make a equal to b by repeated performance of these operations. Hence, the output will be yes for this particular test case. But I would like to, you to pause this video and try to solve this problem for a equal to 30 and b equal to 25. Is it possible to make A equal to B by repeated performing these operations? Please take a moment to pause this video and try for yourself. One thing to note is that since we fixed our D to be 1, we can always make the smaller number smaller of the two. Let's say in this case, in the sample case, what happened, this was A, this was B, and our A was less than B. This what happened, our A is greater than B. It is always possible to start from the smaller number and make it equal to the bigger number by repeatedly performing operations of type 1 on the smaller number. What is operation of type 1? If we fix our D to be 1, let me go back to this slide. If we fix our D to be 1, our operation of type 1 is nothing but incrementing the value of A by 1 and keeping the value of B the same. Operation of type 2 is nothing but decrementing, keeping the value of A same and incrementing the value of B by 1. So these are what the operations transform to. These transform to very simple operations. Let's say our D is equal to 1 always. The operation of type 1 will be what? It will be A plus 1. And then B plus D minus 1 becomes B plus 0 because 1 minus 1 is 0. This is just B. Keep B the same. Operation of type 2, what happens? The new value of A is A plus D minus 1. So 1 minus 1 is 0. This is A itself. And the B plus D becomes B plus 1. So at each juncture, you either have the possibility of incrementing A or incrementing B. This becomes very simple now. That is why whatever A and B value is, there is always a way to make these two equal by repeatedly performing these operations. How? We take the smaller of the two. In this case, A and B, which is smaller. The smaller number is 25. We are trying to make 25 equal to 30. So how do we make this? Operation of type 1 is nothing but incrementing the value of A by 1. Let's say this is our A, this is our B. We can just, swap A and B. We can check the condition if A is lesser than B so that we can always maintain that condition and we can swap. Let's say for simplicity right now our A is 25 and our B is 30, and assume that this condition always holds where our A is lesser than equal to B. So now what happens is we start from the smaller number, and the smaller number is now 25, and we are trying to make 25 equal to 30. There is always a way by multiple repeated applying operation 1. Operation 1 is nothing but incrementing the value of A by 1 and keeping the value of B exactly the same. 25 plus 1 is 26, 26 plus 1 is 27, 27 plus 1 is 28, 28 plus 1 is 29, so 29 plus 1 is 30. So I applied this operation multiple times and finally we made the smaller number equal to the bigger number. We made A equal to B by repeatedly performing this operation. That's what I meant by you can always start at the smaller number and you can make it equal to the bigger number by repeatedly applying this operation. Always, whatever our A and whatever our B is, we know that one number, there are three possibilities. A will be lesser than B, our A can be greater than B, and our A can be equal to B. If our A is equal to B, directly the problem is over. We don't have to do anything. They're equal. If our A is lesser than B, like we saw in these two examples, we can go from A to B by repeatedly performing operation of type 1, which is nothing but incrementing A to A plus 1, A plus 2, etc. until it reaches B. So our A and B can be made equal by repeatedly applying operation of type 1, which is nothing but incrementing the value of A by 1 and keeping the value of B the same. That's what we're doing here. If our A is greater than B, no worries. A is greater than B basically means B is a smaller number, and we'll start from B and we'll repeatedly perform B, B plus 1, B plus 2 until B reaches A now. So whatever it is, we will start from the smaller number and somehow we will make it equal to the bigger number always, because we have the operation of incrementing the smaller number by 1, by 1, by 1. Because at each juncture, we have two possibilities. We can either increment the value of A by 1 or increment the value of B by 1. These are the two opportunities presented to us. Increment the value of A by 1 or increment the value of B by 1. But whatever we do, we start from the smaller number and we repeatedly increment that smaller number until the smaller number and the bigger number are equal. So let's say arbitrarily we have A and B. Now, always it is possible to make A equal to B. There are only three cases like I mentioned. If A equal to B, over. We don't have to do anything. If A is lesser than B, do the operation where you increment the value of A until it reaches the value of B. So it's possible to make both equal. If your a is greater than b, increment the value of b until it reaches a. This is also possible. So always it is possible to make a and b equal. So pause for a second and think about what the solution to this problem will be. The solution to this problem will be extremely simple, and we just print yes. That's all. This might be the smallest solution to a quantum programming problem, because this is a very nice problem that requires you to think and prove that it is always possible to make a and b equal. If it's always possible to make a and b equal no matter what a and b are, do you even need to perform any operations and check or do anything? Nothing. You just have an O of 1 solution where you print yes no matter the value of a and b, because you know a and b will satisfy one of these three conditions. A will be lesser than b, a will be greater than b, or a will be equal to b. In this case, it's over. If a greater than b, you can make a and b equal. You always start from the smaller number and you can make it bigger number, because you are presented with a unique opportunity to increment the value of the smaller number by one, by one, by one until it reaches a bigger number. So this was the main crux of the logic, and hope this is clear. This is a very nice problem. Now let us look at the code for this solution. We know that we input a and b here, but we know that it is always possible to make a equal to b. It is always possible to make a equal to b no matter the value of a and b. We can always make our a equal to b by starting from the smaller number and making it equal to the bigger number. So no matter what the values of a and b are, we will always output yes for every test case, because it is 100% possible. This was the main solution, and I hope you understood the part of how we arrived at this solution, where we will output yes for every test case. Hope this part is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.